Okay, hello everyone. So today is our third lesson of the force and motion part. Okay, so here today's our topic is about momentum and impulse. Okay, so here you can find in the first slide we talk about momentum, and here is a figure right here. It's about the truck on the very high speed road, right? So you can find the truck has a very big velocity. Okay, so that's because the truck is very big, which means that it has a very huge mass, right? So we can say that mass is very big. And also you can find the truck moves very highly speed, so it has a very big velocity. So these two items cause that truck has a very big velocity. Okay, so we can use a new word to represent for the velocity, that is momentum. Okay, so momentum right here we can use P equals to mass times velocity. Okay, this means the truck has a very big velocity. Okay, so maybe you ask that why we use P right here and we don't use M. Maybe you will ask me, oh, teacher Mai Lin, here momentum, it's a capital letter is M, and why you are not using the M? So you can find that we are already using the M in the mass, right? So here we use a capital, doesn't use a capital letter M, but we use a P to represent for momentum, okay? So here you can use momentum equals to mass times velocity, okay? And here, for momentum, we knew the formula is momentum equals to mass times velocity, right? And we already know that velocity is a vector because velocity has direction. Like the car can move forwards or move backwards, or he can turn left and or it can also turn right, right? So it can have a direction. So velocity as magnitude and direction, we can call it as a vector, okay? Just like an arrow, right? Okay. And for mass, we can say that it is a scalar because scalar just has magnitude but doesn't have the vector, have the direction, right? So mass is a scalar. Okay. So once you put scalar and vector together, it's just like a number times an arrow, like 2 times an arrow, right? So in mathematical meaning, we said that it's just double the length for the arrow, so it's still an arrow, okay? So here mass times velocity like 2 times an arrow. So it's still an arrow. Makes sense that momentum is still a vector, right? Because vector is just like an arrow. Okay. So please remember that momentum is also a vector. Okay. So maybe here are some problems like here you can find like the ball has a mass of 1 kilogram and its velocity is 2 meters per second toward right. And you see that here the momentum is 1 kilogram times 2 meters per second equals to 2 kilogram meter per second. So that is about the momentum. Okay. And if you have a velocity toward left in this way, like here, maybe it's -3 meter per second. So please remind that it's -3 meter per second times 1 kilogram equal to here -3 kilogram times meter per second. Okay. So here is difference in momentum. So if there are questions that please determine what is the momentum difference from the initial to the terminal. So you say that there the difference is -3 minus the initial 2, right? So here, momentum changes equals to -5 kilogram times meter per second, okay? So this is how we calculate for momentum, okay? So here is it. And maybe here if an example in the IGCSE test always, and we have a ball and it has a velocity maybe for 3, and it hits on the wall, okay? And after it hits on the wall, he just rebounds back. And we can say that here the difference, like here it seems to be 2, but total momentum change is 5, okay? So please remember for this question, it's very easy to write a wrong answer, okay? And maybe next time we'll watch the video together and we can determine what is about momentum, okay? This is about table tennis, okay? And another word I had to know today is about impulse. So impulse means that, here you can find the second figure that the football player is football on his on his face, right? So you can find maybe he feels like very hurt and maybe I think he is injured, right? So why he was injured in such football hit on his face? Because of that a football has a very strong force on his head, right? On his face, right? And also, the football has a very maybe stayed on his face for a very long time, right? We can say that its time taken is also very high. Okay. So here, force is very big, and time taken on his face also very big. It makes that his face injured. Okay, so we can times these two physical quantities together, and it's force times time taken. So it's just like a lethality. We have already talked about momentum, maybe it's very similar to a lethality meaning. And for impulse, it's also very likely to become a lethality meaning. So here we can write down impulse equals to force times the time taken. Okay, so here is the formula. Impulse equals to resultant force times time taken. Okay, so maybe you can also expand this by momentum. Like here, the ball has a mass, maybe it's not very big, but the velocity of the ball is very fast, right? Maybe in some football competition, you'll find that the football player can hit the ball and the ball to rotate and they have a very big speed, maybe about like 10 meters per second, or maybe about 60 kilometer per hours. Okay, it's very fast speed, just as far as big as a car, right? So here we can say that it's very dangerous. So we have the substitute person for each football player. Okay, so here's about impulse. Okay. And also for impulse, you can find its formula is impulse equals to force times time taken, right? This is impulse. So for impulse, we can say that the force times time taken. Okay, so right here we can find force is a vector, right? Because force not only has a magnitude, but also has its direction. So it's a vector, okay? Just like an arrow. And for time taken, we knew it's a very definite scalar, right? So here is a scalar times a vector. So you know that maybe like a vector times 2 or an arrow times 2 just also equals to an arrow. Just we double the length, right? So here we can set impulse is a vector. Okay, so here you can calculate the impulse like this way. Okay, so please remember that impulse is also a vector. Okay, so maybe here we have an example like we put a football on the ground and we use your hand to drag it. Maybe here the force is 10 Newton. And once you maybe take for 3 seconds to drag the ball, you'll find that the impulse here is force times time taken. It is 10 Newton times 3 seconds is 30 Newton second. Okay, it's like this way. This is impulse. And maybe if you switch your direction for force, like here, like, oh, sorry, my eraser is very big. Okay, so if the force is in opposite direction like this way, like force equals to negative 5 Newton. Okay, so if we take for 2 seconds force to drag the football, we can set here the impulse equals to force times time taken equals to negative 5 Newton times 2 seconds equals to negative 10 Newton seconds. Okay, here is impulse. So if a person want to tell you that, oh, what is the difference in impulse? You can tell them that at the final or at the terminal, the impulse equals to negative 10, and at the initial, impulse equals to 30. So maybe we can say that the difference of the impulse is negative 40 Newton second. Okay. So please remember what impulse changes in your question. Okay. So here is this part. Okay. So in the next slide, we will learn about momentum conservation. Okay. So we already know that momentum and impulse, they're both maybe like they have the same meaning. They're both lethality. They also means that maybe it will hurt on your face, maybe or like a truck, maybe it will hurt other people. Okay, it seems like very big and has a very big velocity, right? So if they have the same meaning, maybe we can write down the third formula, right? Because momentum equals to mass times velocity represent for lethality. And for the impulse equals to force times time taken also represent for the lethality. So you can write down the third formula that is momentum equals to impulse. Okay, maybe right here you have some question about what is momentum and what is for impulse, okay? And here I will give you a very small example for you to understand here. So here, right in my hand, I take a Hong Kong dollar. It's 100 banknote. And right here, you can find this banknote. Maybe if you are very familiar with Hong Kong dollar, here's a line icon right here. Maybe HSBC also likes to use the line pattern. Okay. So for here, you can say that this is a Hong Kong dollar from HSBC. And also there are two other kinds of Hong Kong dollar, like they're from China Bank. Maybe they are also from the Standard Chartered. Okay, like here. There are three banks that print Hong Kong dollar like this way. Okay, so maybe if you are Hong Kong people, right? One day you take maybe $100 to the restaurant and you want to buy a beef noodle, okay? And the maybe the seller tells you that, okay, so our noodle is for $50, okay? So maybe you pay for 100 banknotes for him and he will return you another $50, right? So maybe you have used a HSBC 100 banknote, but he returns you maybe a Standard Chartered $50, okay, like this way. So it can make sense, right? Because this is a very basic calculation, like 100 minus 50 equals to another 50, right? But here you exchange the categories for the banknote, okay? You change the categories of it. But it makes sense because it have the same value. Maybe you can take any kind of note to the shop. You can buy maybe for beef noodles, you can buy other anything, but whatever you take, what kind of money. Okay, so here there is a difference. So by using this banknote, I hope you can know that the relationship between momentum and impulse is just like the different Hong Kong dollar by different bank. Okay, they have the same value, and they have the same. They can buy the same thing. They can buy the same beef noodles, but they looks different. Okay, so here is the meaning of momentum. Okay, so here you can say that the first law we today said that there is three formula. That is momentum equals to mass times velocity, impulse equals to force times time taken, and momentum equals to impulse. Okay, this is the first part. And then the second part, I want to tell you that if there's only momentum, like you take 100 banknotes to the bank, sorry, to the shop, and the seller will tell you that, okay, here is a substance that's worth $50 and you pay for him. Maybe today you have $100 with you, and after that you have $50 with you, right? And the seller gains $50. Okay, like this way. So you can find here, at the very first beginning, you have 100 banknotes, and maybe the seller doesn't have any money. So here your total value is 100, right? And after you purchase your item or the substance, the total amount of your money is 50, and for seller is 50, and your total amount is 100, right? So they just make a banknote transfer between you and the seller, and the total value here stay the same, right? So just like momentum conservation. Or in another view, you can using the tennis ball in your daily life, okay? So here are two tennis ball. And once you use your rod to kick the tennis ball, you can find here, after hitting, the tennis ball just move forward and it will make a collision on another ball. Like here is A and here is B. A will collide with B, right? And maybe here A just stay still. And B has a new velocity, same as the initial velocity of A. Okay, so here you can find that in the very first time, or in the beginning, that A has mass times velocity, right? And B has momentum, mass times zero, so it's just zero, okay? And after they have a collision, and maybe after collision, we can say that the A stops still, or just stay still, right? So it's has momentum of zero. And B has velocity of V, just same as initial velocity of A, right? So here it becomes mass times velocity. So you can find that A transfers in momentum to B and the total value both equals to mass times velocity, right? So this is how momentum can transfer. Okay. So I've already given you many examples to tell you how momentum can transfer to each other and how momentum and impulse can make an exchange. Now let's have a small question right here. So how to use the formula? Like here, you can find in the question, the object experiences a force of 5 Newton for 2 seconds and determine its velocity afterwards, okay? So right here, you can find a ball. It has 2 kilogram mass and the velocity is 4 meters per second. So which means it has a momentum of 2 kilogram times 4 meters per second, right? It has 8 kilogram times meter per second velocity. So if you're just choosing to the right as a positive direction, so here is positive. Okay, so here is 2 kilogram times positive 4 is positive 8, right? And here you can find the object experience a force of 5 Newton for 2 seconds. So if you are using the impulse equals to force times time taken, so here the force just equals to net 5 Newton, right? The time taken equals to 2 seconds, so we can times them together and it's negative 100 Newton second. Okay, so here is what momentum and impulse they have a difference. Okay, oh, sorry, 10, negative 10. Okay, my fault. Okay. So we already talk about that momentum and impulse. There are like two banknotes. Maybe one is from HSBC, another is from Standard Chartered, right? So it's like you're taking $8 banknotes with you, and you're very happy today, and you want to go to the shop to maybe buy a beef noodle, okay? And the seller tells you that the beef noodle worth 10 Hong Kong dollar, okay? So you have to pay for him 10 Hong Kong dollar, and you have to lend another $2, right? So after eating up the beef noodles, you back with home with $2 lending money, right? Your total amount is negative 2 right now. So we can say it's also in this way, when the ball first takes about positive 8 kilogram meter per second, or his momentum, and the force gives it a negative 10. So after he paying for the 10 impulse, he has negative 2 left, right? So this left to 2 means the momentum of the ball, right? So we can have negative 2 equals to mass times the final velocity of the ball. So here is 2 kilogram times velocity equals to negative 2. So we can set velocity equals to negative 1 meter per second. So the ball has a final velocity or terminal velocity to the left just equals to 1 meter per second. Okay, so here is the difference. Okay, so here's an exercise. Please just solve this and try to tell me the answer, okay? Okay, so let's have a quick review for this question. If you doesn't finish your question, you can just try to pause the video and try to rethink about this, okay? Okay, so here is a ball of mass 0.25 kilogram hits a wall at a speed of 16 meters per second, right? Like this way. And then it rebounds back along the original path and has a speed of 12 meters per second. Okay. So what is the impulse experienced by the ball during the impact with the ball, right? So here you can find at the very first beginning, it has a momentum P, maybe initial, equals to mass times velocity, right? It's 0.25 kilogram times 16 meter per second. So total value here is 4 kilogram times meter per second. This is for momentum. And for impulse of the ball, you can also write down the formula that is, sorry, momentum of the final times, maybe at terminal or final, consider that it also equals to mass times velocity, right? But remember that it is velocity. It doesn't mean speed. So here you have to consider about the direction. If you're choosing positive as direction, so here's positive 15 and here's negative 12, right? So 0.25 times negative 12. So the final answer equals to negative 3 kilogram times meter per second, right? So here we have the initial momentum and final momentum. So here it has a difference between 4 and negative 3, right? So the difference equals to 4 minus, or just maybe you can use final minus initial. Negative 3 minus 4 equals to negative 7 kilogram times meter per second, right? Here is the difference. So using negative 7 kilogram meter per second, you can say that, oh, so here it has experienced an impulse on the ball, on the wall, right? So here we can say the wall gives a ball a 7 kilogram meter per second impulse, right? So here we can choose in the D because kilogram meter per second also equals to the unit of Newton times second. Okay, so this is for our today's lesson. Hope you can really understand about the momentum and impulse, okay? So see you next week. Bye.